Hello, my name is Ethan Prieto here. Today we will be going over the beautiful history of an atom. First off, I think we should define what is an atom. An atom is a building block of matter. Atoms are everywhere. Atoms are the building block of the entire world. It's beautiful. I'm made of atoms. This chair is made of atoms. This board is made of atoms. Your phone is also made of atoms. That's the beautiful thing about atoms. But the important thing about atoms is we didn't just get the concept of atoms from nowhere. We didn't just jump to the Bohr model. It took years and years of changes in models and different thoughts and discoveries to figure out what actually is an atom. The reason why is because it's an indirect observation. We can't see it with the naked eye. That's the beautiful thing. So honestly, we can still make drastic changes in the model of an atom. In 100 years, I bet there will be another one. We'll never know. That's the beautiful thing. But in today's video, we will talk about the drastic history of the atom. Okay, so let's start all the way in ancient Greece. Okay, we're going to start in 400 CE. 400 CE. Okay, now you might be asking what happened in 400 CE. Well, we had two people, Democritus, saying that wrong is fine, and Lysippus. They theorized we're made of something. We're not just, the whole world isn't made of nothing. We have to be made of matter, right? We've been knowing that. But what is matter made out of? It's made out of atoms. That's the beautiful thing. So they theorized that matter could be made of atoms, and atoms could be any shape. It can be a circle, a cone, a square. They didn't really know what it could be. That's the sad thing. They didn't really have enough proof. Think about it. Do you think they had modern technology all the way in 400 CE? No, they didn't. So the real question is, why did we have the idea of an atom, but we didn't actually get the invention of an atom until the 1800s, the 1900s? The beautiful thing is, or the sad thing you should say, is Aristotle, a more famous philosopher, he said that the world isn't made of atoms, it's actually made of elements. It's just really sad to me. I don't get it. So people discredited their information, and it wasn't even thought of until the 16 and 1700s, where Isaac Newton and Galileo, they actually decided to do more research on it. And they failed. But you know what didn't fail? Is in the 1800s when you had John Dalton, my goat, the father of chemistry, in 1803. So we're going to jump a big time span to 1803. When John Dalton said that an atom has to be a sphere. He didn't really know what was in the sphere. He didn't know if it was positive or negative charge or anything about protons, neutrons, and electrons. That's way in the future. But what he did know is atoms are everywhere. Atoms is made of matter. I'm going to repeat that a lot because it's true. He also theorized that atoms cannot be created nor destroyed, can only be rearranged. You hear that about energy. Well, think about it. Energy is just atoms. It's common sense, guys. So that's the beautiful thing. He theorized that atoms were just a sphere. A perfect sphere. Mine's not perfect, but I try my best, guys. I try my best. Okay, so we're going to jump from that into the late 1800s. We're going to jump to 1897, where we have a drastic change and drastic development in the atom, thanks to J.J. Thomson, an English professor, an English physicist. He decided to do an experiment, and y'all probably heard about this. It was called the cathode ray experiments. So what he did was he got a ray tube, or a gamma ray basically, and he shot energy through it. And I'm going to draw it real fast, so just give me, I'm not the best artist, so I'm going to try my best. But he basically shot energy through this, and it's going straight at first, right? And it's in a glass tube. I'm not going to draw that, that's extra. But then he decided to put magnets, a positive charge one at the top, and a negative charge one at the bottom. So these are two magnets, and then the ray decided to bend up. So this proved that the positive and negative reflected, and that proved that atoms aren't just matter, they're not just empty space. It actually has charges in it, positive and negative charges. That's the beautiful thing. So now we get our first kind of the first innovation of a new model. It's called the pudding plum model. It makes me kind of hungry. I want some pudding now, okay? So basically this model was made in 1897 by J.J. Thomson, okay? 1897. It was basically just a big sphere that was positively charged. He believed that it was all positive and it had electrons in it. This is when electrons were invented. 1897 by J.J. Thomson. Remember that. He believed that it was a positive charged sphere that actually had electrons all around it. Now, we know this is wrong, but at the time, it was pretty cool. You can't lie. It was beautiful. So now, we went from having no subatomic particles in the atom to now having the concept of a subatomic particle, which now we have the invention, or I guess the discovery of an electron, which is pretty nice. So now we're going to get to Ernest Rutherford in 1908. Okay, pretty soon, it's not too far in time. In 1908, okay, he did something called the gold foil experiment. It's kind of the same thing. He had energy from a source, and then he reflected it off some tin gold, or very thin gold, some gold foil. And this is the center of it. And the energy, right, this is like something surrounding it, actually bounced off of it. Interesting, right? This energy bounced off of the center. Now we recently know that the center is positively charged, and everything bouncing off of it is negatively charged. That's the beautiful thing we learned. So Ernest Rutherford kind of found the nuclei of an atom. So now we have a new model, okay, guys? And it's nothing too much. It's just now our new model is just now what we have is we have a center and we have negative stuff around it. 1908. And we like to call this the nuclear model, okay? Because it was kind of the invention of the nuclei, right? Think of it, nuclear model. That's one way you can remember it. So now let's go to 1913, where this is the most popular model of the atom, okay? 1913. When we have Niels Bohr, he concluded that, obviously the negative charged energy bounced off of the nuclei, but he theorized that it actually orbited the nucleus. In chemistry, we call it the nuclei. It's two different things. Okay, so he concluded that now what we have is we have a nucleus. Okay, we didn't know if it was protons or neutrons yet. That wasn't even discovery until 20 years later. He concluded that there are actually orbits around it with electrons. Very interesting. And that's kind of a very broad discovery of how the atom has changed. Think of it. We didn't even know what shape an atom was, and now we have a whole thing orbiting it. It's amazing. It's incredible. It's kind of beautiful, guys. But now we're going to get to one of the most important forms of the atom. Okay? And honestly, I think this is my favorite form because not a lot of people know about this. And it makes me kind of sad because this is one of the most important models of the atom. And I want to draw it out. And I think this guy's a genius. His name is Erwin Schrödinger. Okay? I probably butchered that, but he was amazing. Honestly, it was quite beautiful. If you think about it, do you really think electrons are in a clean orbit around the nucleus? Do you think atoms are just beautifully organized like this? No. He theorized that's now atoms, and now we're going to talk about the quantum model of 1926, were particles that followed waves. You see, I'm just doing a lot of dots, and it's really hard to do on this chalkboard, but just dots everywhere. It's really hard to do. And then the center. So now, this is it. It looks nothing like this. It kind of throws out everything we learned. Circles followed by circles of negatively charged particles. And it's still true, but now you see it more on a broad standpoint. This looks like a lot of dots. Just a lot of dots, you realize. But this is smart because we learned about the Heisenberg uncertainty principle. And it realized that we can't know exactly where an electron is. We can't know how fast it goes. That's why we use something called probabilistic waves. The beautiful thing about those waves is we don't know exactly where it is. It's just which is the highest probability of it being where it is. I'm basically saying we don't know exactly where it is, but it most likely might be there. It most likely be in this area. So now we're in 1926. This is the beautiful history of this atomic model, of this atom, the history of an atom. And now we're done. And I want to tell y'all some more things, because I didn't really talk about the neutron and the electron, right? And y'all are like, what? Why didn't you bring that up? That's very important. I know it's very important. But the thing is, the proton and neutron, the proton was actually made in 1919 between the Rutherford experiments and the Bohr model. So it was made in 1913 is when the proton was invented. And it makes sense because think about it. I mean, yeah, we have negative charge particles, but what's going to cancel out the negative charge particle? You know what's going to cancel it out? The proton in 1913. And then we jump all the way to 1932, where now we have the invention of the neutron, a neutral particle that makes sure that the positive charge atoms stay in place. That's the beautiful thing. So look, the history of an atom. Beautiful. In modern day, a lot of people will see this. We're going to use the 1913 Bohr model. We're going to see one proton, one neutron, and a cloud around it. That's the modern day model. And this is helium, if y'all don't know. But that's the beautiful thing. So, that's the history of an atom. And I just want to make a conclusion. After watching this video, I think we can all conclude that since atoms are theoretical entities, they can always change throughout time. That's the beautiful thing. Atoms can change. Atoms have many different models. I want to thank y'all for watching this, and I hope y'all learned something. Have a great day. Bye.